Hello everyone, and welcome to Bright English Point. Have you ever wondered how everything in our universe began? Today, we're diving into the incredible story of the Big Bang, the event that transformed a tiny, blazing point into the vast cosmos we see today. In just a few minutes, you'll discover how stars, galaxies, and even life emerged from that extraordinary beginning. Stick around till the end, because this journey through time and space is filled with amazing discoveries you won't want to miss. About 13.8 billion years ago, all the matter and energy that make up our universe were crammed into one extremely small space. Think of it like squeezing all the ingredients for a cake into a tiny mixing bowl. Instead of mixing together gently, though, everything was so concentrated and intense that it set the stage for a dramatic change, a sudden expansion. Now, it might be easy to think of the Big Bang as a huge explosion, but it really wasn't an explosion in the usual sense. It wasn't like fireworks bursting in the sky. Instead, it was the rapid expansion of space itself. Imagine the surface of a balloon. As you blow air into it, every point on the surface moves away from every other point. That's what happened with our universe. The very fabric of space started stretching out, carrying galaxies and stars with it. As space expanded, the universe began to cool down. In those first few moments, the temperatures were unimaginably high, billions of degrees. At these extreme temperatures, even the simplest forms of matter couldn't exist as they do today. Instead, there were only tiny, fundamental particles zipping around at incredible speeds. As the universe cooled, these particles started to stick together, eventually forming atoms, the basic building blocks of everything. To put it simply, the Big Bang marks the beginning of time and space as we understand them. Before this event, there was no space or time, only a state where everything was compacted into an extremely small volume. Once the Big Bang happened, not only did space expand, but time itself began to flow. This means that the very concept of before the Big Bang doesn't really apply in the way we think about time today. Scientists have gathered many clues that support the Big Bang theory. One of the most important pieces of evidence is the cosmic microwave background radiation. Think of this radiation as a faint afterglow, a kind of echo of the Big Bang. Even after billions of years, this radiation fills the universe and provides us with a snapshot of what the early universe looked like. It's like finding a fossil that tells us a story from a very, very long time ago. Another key piece of evidence comes from observing galaxies. When scientists look at distant galaxies, they notice that almost all of them are moving away from us. This observation, first made by the astronomer Edwin Hubble, tells us that space itself is stretching. The farther away a galaxy is, the faster it appears to be moving away from us, which perfectly fits with the idea of an expanding universe. Let's break this down with another simple analogy. Imagine you're baking a cake, and all the ingredients, flour, eggs, milk, and sugar, are mixed together in one bowl. Initially, everything is tightly blended. But as the cake bakes, it starts to rise and expand, filling up the oven. Just as the cake expands and creates a light, fluffy texture, the universe expanded and cooled, allowing matter to gradually form into stars, galaxies, and planets. Even though the Big Bang theory is one of the strongest explanations we have for the origin of the universe, there are still mysteries. For example, scientists are still exploring questions like, what exactly triggered the Big Bang? And what, if anything, existed before it? These questions remind us that while we have made huge strides in understanding our universe, there is still so much more to learn. What makes the Big Bang story so fascinating is that it isn't just about where the universe came from. It's also about how it has evolved over billions of years. From that initial expansion, simple particles formed atoms. Those atoms clumped together under gravity to form stars, and over time, stars grouped into galaxies. Our own solar system, with the sun and the planets, is one result of this incredible process. Understanding the Big Bang helps us appreciate our place in the universe. It shows us that everything around us, our planet, our sun, our galaxy, originated from the same extraordinary event. The Big Bang is not only a theory about the distant past, it's also a key to understanding the ongoing expansion and evolution of the cosmos. Every star we see in the night sky, every planet orbiting a sun, is part of the legacy of that first monumental event. How did the Big Bang happen? Let's dive deeper into the exciting process of the Big Bang itself. How did it all really happen? Although the term Big Bang might suggest a loud explosion, it was not an explosion in the way we normally think about it. Instead, it was a rapid and dramatic expansion of space that changed everything in an instant. At the very beginning, about 13.8 billion years ago, the entire universe was squeezed into an incredibly small, hot, and dense state. Picture a tiny dot so compact that all the energy and matter we now see was contained within it. In that moment, space itself started to stretch out. This expansion wasn't like a bomb going off, but more like a balloon inflating, where every part of the balloon's surface moves away from every other part at the same time. Within the first fraction of a second, something extraordinary happened known as cosmic inflation. During cosmic inflation, the universe expanded exponentially, much faster than the speed of light. It's important to note that while nothing can travel faster than light within space, the space itself can expand at any speed. This inflation smoothed out the fabric of the cosmos and set the stage for the creation of matter as we know it. As the universe expanded rapidly, it also began to cool. In those initial, extreme conditions, the universe was too hot for atoms or even the simplest particles to form. Instead, it was filled with a seething soup of elementary particles, such as quarks and electrons, moving at incredible speeds. For a very brief period, matter and antimatter were created in almost equal amounts. However, a tiny imbalance meant that after many particles annihilated each other, a small excess of matter remained. This leftover matter is what eventually formed the stars, planets, and everything else we see today. As time went on, the cooling universe allowed these free particles to combine and form the first simple atoms, primarily hydrogen and helium. Imagine the cooling process as water vapor condensing into tiny droplets, eventually forming clouds. In a similar way, as the universe cooled, the energetic particles condensed into atoms. This process happened over the course of hundreds of thousands of years and was a key step in building the cosmic structures that followed. Once atoms formed, gravity began to play its critical role. Gravity pulled these atoms together to form the first stars and galaxies. Over millions of years, simple atoms clumped into enormous clouds, eventually igniting nuclear fusion in their cores and lighting up the universe with stars. These stars, in turn, created heavier elements through nuclear reactions, which were later scattered across the cosmos by exploding stars, seeding the universe with the ingredients necessary for planets and even life. Every stage of this process, from the rapid expansion of space during cosmic inflation to the cooling that allowed particles to form atoms, and finally to the gravitational pull that built stars and galaxies, is interconnected. Each step paved the way for the next, creating a chain reaction that has shaped the universe over billions of years. Understanding how the Big Bang happened gives us insight into the origins of everything, from the tiniest particles to the grandest galaxies. It's a story of transformation, growth, and the incredible power of nature working over billions of years. Why is the Big Bang important? Now that we've explored what the Big Bang is and how it happened, you might be wondering, why is the Big Bang so important? The answer lies in its role as the starting point of everything we see today. Understanding the Big Bang helps us grasp how our universe, with all its stars, galaxies, and planets, came to be. Imagine trying to solve a giant puzzle without knowing where the first piece came from. The Big Bang gives us that first piece. It's the event that set everything in motion. It not only explains the origin of matter and energy but also lays the foundation for the laws of physics that govern our world. For instance, by studying the Big Bang, scientists discovered the cosmic microwave background radiation, a faint glow that fills the universe. This glow is like a snapshot of the early universe, offering clues about its initial conditions and subsequent evolution. Moreover, the Big Bang theory connects us to the universe on a profound level. It reminds us that every atom in our bodies was once part of the immense energy from that primordial explosion. This realization can be incredibly humbling and inspiring. It tells a story of transformation, from a singular point of intense heat and density to a vast, ever-expanding cosmos where life could eventually emerge. In essence, the Big Bang is not just an abstract scientific concept. It's a key that unlocks our understanding of where we came from and how the universe continues to evolve, inspiring countless discoveries and deeper questions about our existence. Let's quickly recap. Today, we learned that the Big Bang was the incredible event that started the universe, a rapid expansion from a tiny, hot, dense point that set the stage for everything we see today. This journey from a singular moment to a vast cosmos not only explains our origins but also connects us to the universe in a very personal way. If you enjoyed this exploration into the beginning of everything, please hit the like button, share your thoughts in the comments, and subscribe to our channel, Bright English Point, for more simple and engaging science videos. Thanks for watching, and keep exploring the wonders of our universe.